Okay, everyone. Before I start the lecture, do you guys have any issues, problems, questions about the course or in general about any of the chapters that you learned so far? Any questions? Yes? So it goes through all of your exams. So in order to have an organized way of doing this, I add that to your exam 3, but eventually it goes out of your 800 total, right? So
but
even if you got
reflect on our lows.
what's that?
It won't reflect on our lows grade that you've already used.
So it actually increases your whole grade. So I uploaded your exam 1, exam 2, exam 3 in DBLearn. So now you should be able to see your grades and, I will add the extra credit to your exam 3. But even if you got like 100, you get like 120 depending on how many extra credits you get. So if you got like 80 on exam 1, for instance, then you add all the grades together, it's as if you got 100 on that. So
right, yeah. I guess what I'm asking is, it's like my exam 2 was my lowest, and you matched my 82.
Yes?
But my extra credit homeworks won't go to that exam 2 too.
No, the extra credit, I gave you the 5 points. 5 points extra credit for quizzes 5 and 6 from the book. I added that and 1 grade for your first assignment because it was through email. I just added them.
Oh.
So that is the grade that substituted your lowest grade.
Okay.
But the extra assignment, those grades just go to your exam 3. Okay. So before starting to teach the new materials, first I'm going to talk with you and hopefully people who are watching the lectures from home or in later time also listen to this, and I'm going to make an announcement in DBLearn. So hopefully all 250 of you will be on the same page. So first of all, any questions before I start saying anything? I need your devoted attention to the things that I'm going to say now. Okay. Can anyone tell me, based on conversations that I had with you guys or what I taught before, what is my main goal for this course?
For us to come out with good grades.
Yes, I want you to learn. That is my main goal. And I can't imagine you learn and get a bad grade. Even, sometimes that happens, right? That you learned everything well, but you go to the exam, there are lots of sounds, or you're stressed, and then you get a bad grade. But with extra credits, I'm hoping to resolve that. But in general, if you learn what I'm teaching you, you will be able to get an A in the course. No exception, if you learn. And I know that you have other classes, some of you are working. I was a student myself too. I know the stress associated with being a student. And I want to make this course as easy as possible for you all. That's why I'm assigning extra credits. That's why I record the lecture, upload them, so if you cannot come to the class, you have the chance to watch them later. But what I need from you is also participation and communication with me. If you're not understanding something that I'm saying, just tell me. I won't get offended. I appreciate it. And I can use your feedback to teach better right now and in the course, in general, in next semesters. So just talk with me if you have difficulties with any part of the course. If you don't understand what I'm saying, if you cannot read what I'm writing, if you didn't understand some basic materials before and now it prevents you from learning now. Just come to my office hours, just talk with me, just email me. I will schedule tutoring sessions with you one by one. If you come to me, say that you don't know anything from the course, I schedule meetings with you to teach you all the chapters. But I should see enthusiasm and willingness to do so. I feel like you just want to get a good grade or pass the course by magic. We don't do magic, we try hard. And then that's how we do it. And I'm trying my best to write post study guides for you, post extra videos, have like more office hours. I do whatever I can to make this as easy as possible for you. So to do that, I realize that some of you have like bad grades. As I mentioned, you should see your grade for exam 1, 2, 3 in BBLab. And some of you didn't take the tests. If you missed the test, some of you have excused absences, some of you don't. So in order to encourage all of you and to be fair towards all the students, I'm going to write for you makeup exam 1, makeup exam 2, makeup exam 3. And I'm going to post for you study guides for chapter 1, 2, 3, 4. For the first 4 chapters, which correspond to exam 1 and 2, basically chapters 1 and 2 would be for exam 1, chapters 3 and 4, exam 2. For those, I'm just going to design the questions of your test from the study guides. And I'm going to write the solutions for the problems that I'm posting in the study guide as well. So it would be as easy as possible for you guys to pass the course and also get an A. So as I said, to be fair towards all the students, because there were like so many students that they didn't miss the test, they came, took the test while they weren't doing well, they didn't know that was the option. I make that available to all the students. So some of you, lots of you have already good grades on exam 1, 2, 3. So you don't have to do that, it is optional. Yes?
If you do one of the makeup tests, do you pick the higher grade from between the two, or do you just get whatever grade you get on the makeup test?
The higher grade. Yes?
So anyone can take a makeup test?
Yes. And because, yes?
So are the makeup exams going to be like the normal ones, or are they going to be like the quizzes where we do them at home, or are they going to be done on like a separate?
I'm going to schedule with you times, and this is the thing that I need your participation. Usually I send like when to meet, web pages for you to assign the times that you're available, and only, one time 7 students got back to me, one time 3, and there are like 250 of you. So I'm going to send you individual ones for exam 1, exam 2, exam 3, and ask you what times are you available. And you choose all the times that you are available, and based on those, I schedule times for you to take the makeup exam. And I'm going to probably reserve a room in rent-through, or like if number of students are high, so all of you can take, the makeup exams. And if you did none of those times work for you, just like email me, and then I schedule other times for you. So what I'm saying, I'm just like trying to do my best for all of you, not only to pass the course, but learn and have a good experience with the course. But I need you to also, when I post the study guides, study them. Okay? And I will do that for chapters 1, 2, 3, 4. I already posted the study guides for chapters 5 and 6, and they are like more mathematical, and if I teach you how to name acids, you should know how to do for all, so it's kind of like I cannot just design the questions from study guides, but for the first 4 chapters, I'm going to write really good study guides for you and ask from those study guides. So now I give you the chance to get really high grades, A's on exam 1 and 2. And to be fair towards all the students, all of you are welcome to take that, because otherwise it would be like not fair towards everyone. Any question about this? So even at this point, if you decide to do well on this course, you easily can. But you should study, and then you should like put more effort. And I'm putting my effort too. I'm going to post the study guides, write them for you, make this as easy as possible. Any questions about this? Okay. And I'm also going to send an announcement in BBLab, and if you don't receive, based on my understanding, you should receive emails when I post a notification or announcement in BB Learn. If you don't, just check BB Learn every day so you make sure that you won't miss any announcements. So I'm going, today or tonight, I'm going to send you an email asking when are you willing to take exam 1 and what is your availability, and go to that page, pick as much as time as possible so I make sure that I can handle this. Otherwise it would be like if each of you just email me individually, it's like 250 of you, and I'm going to have like 3 makeup exams. I cannot manage that, so just like, work with me on this. Okay.
Question of future, is our final cumulative?
Yes. So that's why this is a really good opportunity. You have like at least 10 chapters on your final exam. And if you have difficulties with like chapter 1 or 2, 3, 4, 5, it's not manageable in 1 week. But now it's completely manageable. I'll post like 4 Word documents that have like each chapters 1 to 4, so you can study those, do good on your, exams 1 and 2, and then the rest of the chapters we work together and then we make sure that you understand well. So now it's doable. Yes.
Can there be a study guide for the final, or do you want us to just study all of the chapter study guides?
So you should study all the, it would be, so I'll post, I already posted study guide for chapter 7. I'm going to do for each chapter individually, except chapter 5 and 6 that I posted them together. I'm going to do each chapter so you understand each chapter well, yeah.
Okay.
But maybe I'll, will post some solved problems for your final exam to help you understand. But the study guide is for like each chapter because I want to make sure that all of you learn. Okay. If there is no further questions, no questions? Everything's good? Okay. So now I'm going to start teaching chapter 9, which is about electrons in atoms and periodic table. And to start this chapter, I'm going to talk about, or rather your book talked about blimps, balloons, and models of the atoms. So if you see a video of the blimp and you saw them like in different sporting events or like, different celebration events, so you see them. And instead of having air in them, they have helium. Because helium is much lighter, and because of the buoyancy, does all of you know what buoyancy is? It's the ability, to be floated in the air or in the water. So these blimps can float in the air. And I also wanted to show you a video, but I was just like talking too long. So now I just show you the picture from your book. So this picture, and if I find my pen, I can have also point here too. So this was called Hindenburg blimp. That instead of having helium, it was carrying hydrogen. And some of you may know that pure hydrogen is highly explosive and dangerous. So it was an accident, and there was like hydrogen leak, and this blimp caught fire and then was destroyed in a matter of seconds. This is how dangerous pure hydrogen is. That's why there is lots of controversy now about fuel cell cars that carry pure hydrogen, because if there is an accident, the accident would be much more catastrophic because they have pure hydrogen, because hydrogen is highly explosive. But if this blimp, if it had like helium, not only it wouldn't have caught fire, but also helium is like fire extinguisher. So it would prevent the fire. So now we want to know why hydrogen is really explosive and is really reactive, while helium is not reactive at all. And if you remember from chapter 3, helium is a noble gas. So this is the main, and I also kind of have a picture of a page of your book. So kind of like have you attracted to the book too, so you see how cool it is to study that. So you have the same book, just like online version. So this is the main objective of this chapter, to know, to understand why some chemicals are so reactive, why some of them not reactive, what defines the state of different elements, why we have some of them are liquid, some of them are gas, why we have these properties of different elements. And kind of to go back to what we learned before, I thought it is useful to kind of have a review, because now hopefully most of you want to study previous chapters to get prepared for your final exam, and also for the exam 1 and 2 makeup exams that I'm going to give you. So here, from chapter 3, and here, it has the page 2. You remember that in general, we categorize matter to pure substances and mixture. And now we know that pure substances are categorized to elements and compounds. And do you remember, can anyone tell me that what is an element? And I'm kind of highlighting the definition here too. Can anyone just tell me based on this, what is an element?
A substance that cannot be broken down into simpler solutions.
Exactly. So an element cannot be broken into simpler substances. And do you know that how can we refer to elements? If I want to know the name of the elements, where would I go? Based on the chemistry materials that you learned. Or if I ask you what is atomic mass of carbon, where do you refer to? Exactly. So you have the list of your elements in the periodic table. And this is kind of like the picture of periodic table from back of your book. And if you remember, you have different group of elements. And can anyone, or do you guys remember Mendeleev, the chemist, the scientist? So you learned in previous chapters, chapter 3 and 4, that when he wanted to arrange elements, he did so by atomic mass. Basically, based on mass of the elements, he put them together. But now, later on, scientists went back and realized that the best way to arrange elements is based on atomic number. And can anyone tell me what is atomic number?
The number of protons.
Exactly. So if we put the elements based on the increase in atomic number, so here, it's and then you see that atomic number is the number on top, 1, 2, 3, 4, 5, 6, 7, and then so on and so forth. If we arrange elements based on increase in atomic number, we start seeing a pattern in each group. And then you remember, maybe it's best that I go to the next image that I have here. You see that this is kind of like chapter 4. If I can highlight it here. Atoms and elements, and then you have your periodic table and all these cool things. And your book talked about different groups. So you see you have group 8 here, noble gases here. And if you go to the book, you can just see more detail, helium, neon, argon, xenon, radon, right? And then group 7A is halogen, and then alkali metals group 1, except hydrogen, which is not a metal, but it's still very reactive. The properties are the same for all of these elements in one group, but hydrogen is not metal, and then alkaline earth metals, and then here you have like transition metals. So what I'm going to demonstrate to you is that if we put elements by the increase of atomic numbers, which is like the number of protons in them, and then sort them and put them in a table, which is like your periodic table, we start seeing trends in each group. And then here, you realize that, if we look at the atoms in each row, we call them each period. And then here we have like different groups, right? Then we get group 1A, 2A. So these are all review. But as I said, even if you don't know anything about the course, here is a good starting point. I help you. We learn everything together, okay? So now you know that elements are in periodic table, and some of these can be reviewed, for sure for most of you or some of you. But now it's a good time to whether learn these or review them. So any questions so far? So if I ask you in the exam that if we put, is the following statement true or false? If we put elements or sort them by increasing atomic mass, we see a trend in their properties. True or false? You got tricked. If we sort elements by the increase of their atomic mass. Exactly. So this is what Mendeleev did previously. He sorted them based on their atomic masses. But the periodic table that you see here, it's sorted based on atomic number. Remember, we had like here, like 1, 2, 3, 4. So you see properties in each group in your periodic table, which is sorted based on atomic number. And now and out of the, okay, we're back on track and it's recording. Okay. So you see properties if we sort atoms by the increase in atomic number. Okay, so here I just sorted what I mentioned to you, that we have like the group 1A alkali metals here. And then we have like group 8A noble gases, and you know that these are like highly highly reactive, while these ones are not reactive. And there are two ways, or there are like two theories and models to explain these behavior of these groups, or like the fact that all elements in one group have similar properties. So those models are Bohr model. The other is quantum mechanical model. So for now, I just teach you the names, so you will be familiar with the names, but we need some other tools to learn in order to be able to understand these models. But right now, just remember that to explain why we observe the behaviors of group of elements such as 1A or 8A, we have like these two models, Bohr model and quantum mechanical model. And something that your book mentioned, and I thought it would be interesting to kind of this is the beauty of studying and then reading the book, because sometimes I cannot cover everything in the class, but some of these are like statements that are really interesting from like great people, scientists, that you can just like study, learn, and then kind of like, first of all, enjoy, and then know, and then it's kind of like trivia, knowing things, and then when people you hear them in the news or like, kind of like from other people, you have an understanding of what's going on. So there are like different, as we said, one of the models was Bohr model, which is like named after Niels Bohr, and the other, theory was, one of the contributors was Erwin Schrödinger and also Albert Einstein. But your book kind of did discrimination, didn't put his picture here. I think the book assumed that you know who Einstein is, so the book didn't include his picture. But anyway, and then there are like some sayings by the scientists that I'm not going to ask you in the exam, but I'm thinking that it's worth mentioning that, for instance, Bohr mentioned that anyone who is not amazed or like shocked by quantum mechanics didn't understand it, because how strange this theory is. Or like Schrödinger said that I don't like it, I am sorry I have ever anything to do with it. And the interesting one is that Einstein said that God does not play dice with the universe. And when I teach you about these theories, quantum mechanical model and Bohr's model, you know that what it means that God doesn't play dice, because it has like uncertainty, it states uncertainty about the place of electrons in atoms, and it's so strange. So anyway, I thought it is like cool to have also like, you see these faces and kind of like when you hear a name, you have a face associated with it, and also know how other scientists felt about these theories. So if you have like at first it's like difficult to understand the theories, you don't, take it personally. Even these guys were like so amazed and shocked and, were in disbelief with these theories. Anyway, any questions so far? Okay. So in order to understand these models that I just mentioned, like Bohr's model and quantum mechanical model, you should know some terminologies. And to do that, your book first talks about light. And specifically, I guess I just first write this and then I show you the picture, or just like write it myself. So, section 9.2 is about light, electromagnetic radiation. Because in order to understand, the Bohr model, quantum mechanical model, we are going to use terminologies such as wavelength, we're going to talk about photons, we're going to talk about frequency, energy, and all those that, first you should have familiarity with basics, and then we can go talk about these and like the theories that I just mentioned in our next session. So, you guys might have noticed that unlike other matters or like things that we encounter, such as this pen, like the wood, all the things that we can touch, and feel them, light is not like those. In other words, light is not matter, right? You cannot, I cannot like grab you some light, give you some light, right? It's not matter. But what it is electromagnetic radiation, and I'm going to write this here, that light is not matter. It means it has no mass. I cannot tell you calculate the mass of certain light. It doesn't make sense. It's not true, because light has no mass. Light is a form of electromagnetic radiation, a type of energy that travels through space at a constant speed of 3 multiply by 10 to the power of 8 meter per second. And then your book converted that to miles per second too. So you have a better understanding. And as we mentioned before, when we were talking about mole, these numbers, when we have like power, the numbers become much bigger compared to, when they don't have big power associated with them. So this number is so large that if you have your book says that, at this speed, a flash of light generated at the equator can travel around the world in 1/7 of a second. So this is really fast. This is what your book is trying to say. That's why if you see lightning in the sky, first you see it, and then you hear it sound like 8 seconds or 7 seconds or like some seconds after. Or like it's the same with fireworks, you see fireworks and then you hear the explosion sound like sometime after. So this is because the speed of light is much higher than the speed of sound. Does that make sense? Is this clear? Yes?
Is that first one 3 times 10 to the 8? Is that meters per second or second?
Yes, this is meter per second. Oh, this one, the second one is miles per second. Any more questions? So I'm going to now talk about waves. And you probably encountered waves previously, like when you go to the ocean, you see like waves coming to the sea, right? And if you look at it from the above, they have like, kind of like a round shape. Or if you like have a rope, if I, have a rope and then fasten it like kind of like to this doorknob here, and I kind of like shake it or move it, you see kind of like the motion of the rope kind of like this, right? Or like the same thing that I was just saying right now. Let me try to bring this picture here. So if you have like a droplet of water, coming to the body of water that is still, and then you drop a rock, for instance, in it, you see the waves being generated, right? So now we kind of want to, oh, okay, I thought that I didn't press the thing. So anyway, now we want to talk about waves and some definitions associated with waves. So imagine that we have a wave, and I try my best to draw this kind of like uniformly. Okay. Kind of succeeded, not completely, but okay. So here we characterize waves by their wavelength. And the wavelength is the distance between two wave crests. So here we call this point here crest of the wave, and then here we call this point trough. So the distance between two adjacent crests, we call that a wavelength. And we write that with the letter lambda. So I'm going to write here and this is your figure 9.1. I figured it's just like maybe better to just draw it myself so you have better understanding. Any questions? Okay. So the wavelength of light, lambda, is the distance between adjacent wave crests. So you see, if we have like, as I mentioned in the example that I just gave, that we have a rock, we drop it in the body of water that is still. You can see the wavelengths with your eyes, or kind of like in the sea, or in the example of the rope that I gave you. If we just take a picture, if we have a really good camera or a really good iPhone, maybe, probably, most probably, certainly, you can kind of take a really good picture, and then you can see the distance between the adjacent crests, and then you can, determine the wavelength. For light, you see these wavelengths, the difference between these wavelengths with the color. So this is kind of the beauty of it, that when you have like different lights, when if you have like, probably you saw that, like in the rainbow, you are able to see different colors of the visible light. Or, for instance, if you have a prism, and some of the chandeliers and kind of like other lights, they have like prisms in them, and then you see kind of like rainbow colors in the walls, and you see these spectrum of visible light. So they have like different colors because they have different wavelengths. So when it comes to electromagnetic light, we see the difference in different wavelengths by different colors. So I'm just going to write that here so I can just ask you in the exam. For visible light, wavelength determines color. So I can whether omit this and then give you 4 options to fill that out, or like color. So is that clear? Does that make sense? To kind of even make more sense of this, I'm going to show you the picture of your book. So here, as I mentioned to you, and I kind of study with you too, said that waves are generally characterized by wavelength, the distance between adjacent wave crests. For visible light, wavelength determines color. For example, orange light has a longer wavelength than blue light. White light, as produced by the sun or by a light bulb, contains a spectrum of wavelengths and therefore a spectrum of color. And you see, the colors in a rainbow, right? Can anyone tell me the colors in a rainbow, or like in the visible light spectrum in order?
Yellow, green, blue, purple,
Indigo, purple, yes. And you kind of like can, if you have like some sense of colors, or like, trying to, if you want to arrange these colors, or maybe I use black here, it's like red. Closest color to red can be orange, right? And then you have like orange, and then you have yellow, and then you have green, and then you have blue, and then you have, you have indigo and violet. So kind of like here, red, orange, yellow, green, blue, indigo, and violet. So can you see the gradual change in the colors? So when you see a rainbow, it's kind of like, it's not easy. I mean, it is not like really straightforward to distinguish the colors, right? Here, you kind of, if I ask you what color is this, you should kind of like try to distinguish because they are like really like a continuous spectrum. Does that make sense what I'm saying? So you don't see, if I just generate the colors here, like you don't see red, like they're not like this distinct. You know what I mean? It's kind of like a spectrum, and then you see the gradual change in colors. So now, one thing that you should know is how these wavelengths are related to the colors. So I'm not going to exactly say that what wavelength is like this color over here, But what you should know is that red has the longest wavelength, and in next page that I'm going to teach you, I show you the corresponding figure too. But you should know that red has the longest wavelength and violet has the smallest wavelength. And something else that your book talked about is the concept of frequency. So since it's like written here, I just like talk about it from this standpoint. So one characteristic of waves is wavelength. The other one is frequency. And the frequency is the number of cycles